Assalamualaikum and hello. Let's continue with IUPAC nomenclature of disubstituted benzene. Di means two, so it means that you have a benzene with two substituents attached to it. So there are two cases here. The first one is two same substituents where you are going to have, for example, this structure. So you got benzene with two chlorine atoms attached to it. So what we're going to do for this naming, we are going to name the benzene as its parent. So the whole benzene ring will be the parent, this one. And your substituent is going to be your chlorine atom. So you got two of it. So it means that two identical substituents. So how you want to give the naming, make sure you follow the same rules as before. You have to give the number for your substituent. Usually we are going to start with number 1, whichever side you want, because you got two same substituents. So I'm going to start from here. This is going to be first carbon and this is going to be the second carbon. If you take a look carefully here, you got no double bond here. However, please remember that when you learn about aromatic compounds, especially for the benzene ring, you have to remember benzene got calculus structures, which is a resonance between two benzene rings, where you can show the delocalization of pi electrons in the ring. So if I want to give the numbering, I'm going to give the numbering whichever side I want, even though there is no double bond here, because you have to understand the calculus structures between two identical benzene ring can be in this form as well. So I hope you are still remember about this lesson in the previous video. So let's get back to this structure. How you want to give the name, I'm going to start with my prefix, my substituent. So I got 1, 2 dash two identical substituents. You have to put di, and in this case there are chloro and my benzene as the parent. So this is going to be my full name for this structure. Next, we will go to disubstituted benzene with two different substituents. This is a special case for benzene ring where we are going to depend on the relative position of your substituents on the benzene ring. If you got one substituent, for example X at first carbon, if another X attached to this carbon at the right or this carbon at the left, it means both of them are at position carbon number 2. So you can also give the name 1, 2 as or 2, because two substituents here are attached to carbon 1 and carbon 2. Same goes for 1 and 3. If you got two different substituents attached to these carbons, so you are going to give another name for them as meta, small letter m. And same goes for position carbon number 1 and 4, you got para. The next one, the most important thing that you have to understand when giving the name for two different substituents attached to the benzene, you have to select one substituent that gives a new parent name. So this is where you have to memorize the priority order of common substituents. I give you here, the highest priority is going to be carboxyl group. So automatically the carbon that attached to this group will be numbered as first carbon. And then the priority order becomes least important until X, which is usually we use as a symbol for halogen. So these all you have to memorize. Usually I hope all of you can understand that carboxyl is the most priority. So when you have carboxyl attached to the benzene ring, please remember from the previous video, you have the common name which is benzoic acid. So benzoic acid is going to be your parent. And extra information here, for your information, benzene is categorized in alkyl group. So I hope you understand the position of benzene is in this position. So let's try a few examples based on example 2. Let's focus with structure A. For structure A, you have to determine whether your structure can give a different name for this one. As you see here, you cannot give different name because the parent will be always as benzene. So, my parent will be benzene in this case. So just label, the parent will be benzene. So I'm going to write it down here, a notes for me. And the next one, I can see that my substituents attached to different carbons. So I'm going to determine whichever carbons that has the substituent as carbon number 1. If I start here, it's going to be 1 and then 2. And I got 2 substituents and the name of this substituent is bromo. However, I got 2 same substituents, so the name will be dibromo. So now if I want to give the full name for that, we are going to give the numbering for our prefix, which is numbering for our substituents. So I'm going to start with carbon number 1, 2, dash, dibromo, and then my parent will be benzene. So this is the name for my structure A. Now, I'm going to let you know that if you realize here, position carbon number 1, 2 here can be named in different way, which is ortho. So how I want to give the name for this structure by using ortho-meta-para system, I'm going to write it down as ortho O dash dibromo benzene. So both namings are correct. Now let's focus with structure B. I also got the same case with structure A, however the position of my substituents change right now, which is at first carbon and the third carbon. So I'm going to give the name as 1,3 dibromo benzene. And if you take a look carefully, for 2 substituents that attach to carbon 1 and 3, we can also give the name as meta. So I'm going to write it down as M dash dibromo benzene. So this will be another name for structure B. Both are acceptable. Now let's go to structure C, where my substituents right now opposite to one another. 1, 2, 3, 4. I give the numbering for my substituents. So the name will be 1,4 dash dibromo benzene. And if you see this one clearly, position carbon number 1 and 4 for 2 substituents will be named as para. So I'm going to write it down as small letter P dash dibromo benzene. And this is another name for structure C. And both names are acceptable. I hope all of you are clear with example 2 for structure A, B, and C, how you want to apply ortho-meta-para system based on different position of substituent. Now we are going to focus structure D. Structure D, you got benzene. However, please be careful right now because this benzene is attached to different group. The first group is this one and the next group is this one. So this is alkyl group, CH2, CH3. However, this one is carboxyl, or you can condense the structure as COOH. Benzene that attached to COOH can be named as benzoic acid. And if you take a look here, you have the priority case between COOH and R between COOH and R group here, which one is more priority? You can see that COOH is the top one. So I'm going to choose COOH that attached to the benzene ring as my big parent. And the name for this one is benzoic acid. So my parent will be benzoic acid. Please make sure you put a space between zoic and acid. Due to this group, COOH group attached to this carbon, automatically this carbon will be numbered as carbon number 1. So my numbering will start from here. And then the next numbering is to the next substituent. Now I'm going to give the name for my substituent, which is this case is ethyl. So ethyl at position carbon number 2. So I'm going to write my full name for structure D is 2-ethyl benzoic acid. And can I give another name for orthometa-para system in this case? Yes, you can give then another name for this one because you still got the benzene which two different groups. So I can see that two different groups attached to carbon number 1 and number 2. So we can classify that position as ortho-ethyl benzoic acid. This will be another name. So this numbering is referring to ortho. Now let's go to the next one, structure E, where I also got the same structure as D. However, the position of my ethyl group is not at carbon number 2 anymore. It will be at carbon number 3. So if I give the numbering, this one is carbon number 1, 2, and 3. So the name for this structure will be 3-ethyl benzoic acid. And if I want to give the orthometa-para system for this numbering, I'm going to write it down as meta, small letter m, dash ethyl benzoic acid. And let's go to the last structure, structure F, where I also got the same parent. And my position for alkyl group, my ethyl, is at position carbon number 4. So this one will be 4-ethyl benzoic acid. And from here, number 4 can be named as para. So I'm going to write it down as small letter P dash ethyl benzoic acid. So I hope all of you are clear how to give the name by using orthometa-para system for example 2, and also how to apply priority case when you have two different substituents that attach to the benzene ring. We will continue in the next video. Thanks for watching. Bye!